Let's solve this question. A hose pipe ejects water at a speed of 0.3 meter per second through a hole of area 50 centimeter squared. If the water strikes a wall normally, calculate the force on the wall. Assuming the velocity of the water normal to the wall is 0 after striking. So let's imagine the problem. We have a hose pipe and then water is coming out of it, and we know that when water comes out of the pipe it has certain force. So here we have a wall and water strikes with the wall, and we assume that the force is purely horizontal, or the water is purely horizontal. So we need to calculate the force F on the wall, and we are given the velocity v of the water with which it is flowing through the pipe, which is 0.3 meter per second, and we also know the area of the hole because we know a hose pipe is circular and we know its area A, which is given, it's 50 centimeter squared. And just remember, when we actually solve the question, we have to change centimeter squared into meter squared before we start any calculations, because I told you we need to change the units into SI standard units so that all of our calculations are consistent. Anyway, that is the work for later use, because first we need to understand the question and a possible solution, or at least the scheme of solution. So we are given only the velocity of the water inside the pipe with which it is flowing through the pipe, and then we know the area of the pipe A, which is 50 centimeters squared. And we will assume velocity of water normal to the wall, and yes, we can see that it is purely horizontal wall, force is purely horizontal, and wall is purely vertical, so they are normal. And velocity of the water velocity of the water which is normal to the wall is 0 after striking. Of course, after striking the wall we will assume it's 0. So what could be the solution? So we need to calculate the force, and if you remember Newton's second law, it tells us about the force F. So let's see what it is. F equals mass times acceleration. Okay, so we got a clue how to calculate the force F, and we know that it is related to the mass and then acceleration. Okay, and if I go next, I can write it like mass into the change in velocity over time. Okay, so acceleration is change in velocity over time. Why did I write it like that? Because I know we are given the velocity 0.3 meter per second. So if we are given the velocity, so I have to transform it into velocity, because velocity is given to me, so I am trying to transform it into velocity. Okay, so I can write it like that: mass over time into velocity. Okay, so now I have a clue how to solve the question and calculate the force F. So I know what is V because it is given, and I can calculate mass M, but it's not only mass M, it's mass per unit time, M over T. So that is a bit tricky. mass per unit time. Is there any way to calculate mass per unit time? Maybe there is a way, but we miss some background knowledge about that. So let's review that background knowledge and then we will come back to solve this question. Okay, so let's learn about volume flow rate. What is volume flow rate? Volume flow rate is volume divided by T time. So it is measure of how much volume of something is passing through a unit area per unit time. So just remember, this is uppercase V, which is for volume, and it's not for velocity. So don't confuse it with velocity, because usually for the velocity we use a lowercase v. Anyway, so volume flow rate is volume per unit time. Let's elaborate it further. So just suppose we have a volume of water which is 4 meter cube. Here we have a pipe, and this is a unit area. So we will use it as a reference. This is the water, and then we have a certain volume of water or liquid, whatever you consider it, and this volume is 4 meter cube, and we want to know the volume flow rate. So we want to know how much volume of water passes through this unit area. And let's do an experiment. So here we have the timer, and I want to know what is the volume flow rate. So let's do the analysis. So let's see. Okay, so one volume is passed, then another, and then the third one, oh, then fourth one, and the fifth one. And this is the end of my experiment. So a certain volume of water pass through the unit area, and I have calculated all of these volumes and the time during which all of these volumes passed through the unit area. So now I want to calculate the volume flow rate. What is that? Let's see. So as we know, volume flow rate, we represent it with Q. It is volume over time. So now the volume is 5 times 4 meter cube, because each of these is 4 meter cube. So because they are 5, so I multiplied with 5, because that is the total volume of water passed through the unit area. And then the time, because we need to give the time during which all of these volumes of water passed through the unit area. And here is the timer, which is telling us that all of these 5 pieces of volumes of water passed through the unit area in total 10 seconds. It took them 10 seconds for all of them to pass through. So I just put the total volume of water passed through the unit area divided by the total time, and here is 2 meter cube per second. So what does it tell us? It tells us that in 1 second 2 meter cube of volume pass through this unit area. So it means half of the volume, only the half, pass through the unit area in 1 second. Or in other words, I can say that it took them 2 seconds to pass this whole volume of water through the unit area. So it took them 2 seconds. And if I rerun this animation, you can see that when one whole volume of water passes through this unit area, it takes 2 seconds. So I am going to rerun this animation, and you can see the 1 is passed, and we can see that now the time is 2 seconds. For the next time is 4 seconds. For the next, of course, it's 6 seconds, then it should be 8 seconds and 10 seconds. So this is how we calculate the volume flow rate. It tells us how much volume of water pass through a unit area per second. In 1 second, how much volume. And this is telling us that 2 meter cube was passed through the unit area in 1 second. So the half was passed in 1 second, and the total piece of volume passed in 2 seconds. So let's rerun this animation with another setup. So now assume that this volume of water is still 4 meter per cube, but let's do the experiment and see what happens. Okay, this one seems like the volumes are passing quickly, is faster than the previous case. So let's calculate the volume flow rate for this problem. Okay, so the same formula, we need to give the total volume and the total time for those volumes which pass through this unit area. So as usual, because they are total 5, 1, 2, 3, 4, 5. So 5 times 4 meter cube, because each one is 4 meter cube. And then the total time taken, I can see from this scale that it is 5 seconds. Now this time the same volume, and there are still 5 pieces, but they passed in 5 seconds. If you remember, in the previous case it was 10 seconds. So it means this time they were faster. So if they were faster, we can see that it is 4 meter cube per second, and each of this volume of water is 4 meter cube. So it means each one of them pass through this unit area in 1 second. And if I rerun this animation, you can see that the time scale tells us the same: 1 and 1 second, second and 2 seconds, third volume, then the fourth volume, fourth second, fifth volume, fifth second. So this is how we calculate the volume flow rate. So now I tell you something more into it. This quantity is not very useful because we need to know the volume and then per unit time. So instead, I can represent this quantity in some other quantities which are useful. So let's calculate that one. So it is the same formula: volume flow rate. This is total volume per unit time. And I told you that in practical examples or in practical problems, this is not a useful formula, because how do we know what is the volume of water inside the pipe? It's not easy to find, right? And then we have to calculate the time it took for the volume to pass through a unit area. But I can represent this thing in some other quantities which are useful. For example, I can write this volume as area into the distance d. This distance d is actually the width of this cylindrical volume of water, because water is inside a pipe, so it will have the cylindrical shape, right? This area A is area of the face of the circular face of the pipe, and this is the width of the cylindrical volume of water. So I can represent this volume as area multiplied by d, which is width of the volume of water. So I wrote it like that: area into d. So I split the formula for the volume into A cross d. If you are still confused, why am I doing that, why am I writing the volume of this whole piece as A cross d, let me remind you that what is the volume of a cylinder. Do you know what is the volume of a cylinder? So here we have a cylinder. This is the circular face of the cylinder. And do you know what is this? This is actually area of this circular face multiplied by the height. Here I am writing it as height of the cylinder. So same is the case in the previous example where we had a volume of water in this shape. So let me go back and tell you that this is actually the height. I showed you as a height in the volume formula, but here we are representing it as D. So I can write the volume as A. A is area of the circular face multiplied by height of the cylinder, or here I am writing the height as D. So I can write it as A cross D over time. Now further I can write it like A cross D over T. But what is D over T? Let's find out. So D over T is the distance traveled by this volume of water equal to the distance D. So if for example here I have the volume of water, and if it travels a distance D like that, so this is the velocity of this volume of water which has covered the distance D. So D over T is the velocity of this volume of water which is passing through the unit area. So I can write it as A into the velocity of the volume of water which has covered a distance D, which is equal to its own width of, or you can call it height of the cylindrical shape. So this formula will help us to solve that problem. The next quantity which will help us to solve that problem is density. Density equals mass per unit volume. So density tells us how a certain mass of something is packed into a volume. For example, here I can say that certain mass here, another mass, so here I can say that a mass is packed inside this volume, and you can see a lot of mass is stuffed into this volume, because usually we have the choice sometimes to pack a certain mass of something into a smaller volume. So it means it has very high density, it has medium density, and it has low density. So density is mass per unit volume, and how much mass is packed into a given volume. So that is density. So for some materials, for example water, they have a fixed density because we don't have any control on them. If it is a free water, not under any pressure, so it has a fixed density, which is density of water is 1000 kilogram per meter cube. So this is the density of water. So it will also help us to solve the problem. So I think now we can go back to solve the question. Okay, so we are back to the question. So we left our discussion here that this force equals mass per unit time multiplied by change in velocity. Remember, this is change in velocity. So we need to calculate change in velocity. Of course, is easy because we know the initial velocity 0.3, and they told us to assume the final velocity 0 after striking the wall. So the next is we need to calculate mass over time. Okay, so let's go to the next slide. Okay, so force F equals mass divided by time into change in velocity. So this is not a problem, but we need to calculate this one. So how can I calculate m over t? Okay, so we discussed like that density d equals mass per unit volume. So just remember, this is v for volume, not for velocity. So let me write these lines so that you will remember it. This is for volume. So I can write it like m equals d density multiplied by volume, and I need to calculate m over t. Just see, because we are calculating the force by which the water will strike the wall, and to calculate the force we need to calculate m over t, because we already know the change in velocity, or we can calculate easily, but we we are confused for m over t. So if I want to calculate m over t, here is the density formula which I have rearranged, because I put the mass on one side and rest of the quantities on the right side. So I need to calculate t. So let me divide this equation with t, because we want to know m over t, right? And then I can divide this side as t. Or if you know algebra, I can also write it d. D is for density, just remember it, and then volume. This is uppercase V, which is for volume, over T. Okay. So I can calculate M over T from the density and V over T. So I know the density of water, because in the question they wrote it that it is water which is flowing through the hose pipe. So I know the density, it is 1000 kilogram per meter cube. So I know this, but I don't know V over T. So how can I calculate V over T? V over T. So we have already discussed some background knowledge. So do you know what is V over T? Volume per unit time. Volume per unit time. So do you know that? Let's have a look on that slide. Okay, yes, so we just studied like volume per unit time. It is the volume pass per unit area, and volume is flowing through a pipe, and we can calculate it if we know the area of that volume of water, which is equal to this is the area of the circular face of the liquid, and of course this area is equal to the area of the pipe, because water just adopts the shape of the pipe. So if you want to know the area of that volume of water, this area is actually equal to the area of the pipe, the hose pipe in our problem. And then velocity is the velocity of the liquid inside the pipe. So it means I can calculate V over T by multiplying area of the circular area of the pipe multiplied by the velocity of the liquid inside the pipe. So let's go back to the problem. Okay, so we already know the velocity, which is 0.3 meter per second flowing through the hose pipe, and we are also given the whole of the area 50 centimeter squared. So it means I can calculate m over t by multiplying the density of water, which I already know, it is 1000 kilogram per meter cube, and I can also calculate v over t, because v over t equals a into the velocity of water, and a I can calculate area, because in fact I don't need to calculate area because area is already given. I just need to convert it into meter squared, just to represent it in SI standard unit. Velocity is already given, so I need to multiply these two quantities which are given in the question, and I will get V over T. And once I get V over T, I will multiply V over T with the density of water, and I will get M over T. Okay, so my problem is solved. Once I get M over T, I will just multiply it with change in the velocity to find the force of the water with which it will strike the wall. So let's go to the solution. So now I will calculate V over T. Let's go to the next slide. And I know that V over T equals, let me have a look on the formula again, volume flow rate, and V over T equals area of the circular face multiplied by the velocity of the liquid inside the pipe. So A multiplied by velocity. So A multiplied by V. So just remember, this V is the velocity because this is lowercase e. And if it is volume, I will represent it with this capital or uppercase V. So just remember the difference between two. So this is A, area of the circular face, which is given here, and V is the velocity of the liquid inside the pipe, which is also given here. But before I can plug in the value of the whole area 50 centimeters squared, I need to represent it in meter squared because that is the SI standard unit. So let's convert it to meter squared on another slide. So area A equals 50 centimeter squared. So anybody can convert in their own ways, but how I remember is that I can write it like that. I can see that 100 centimeters are 1 meter, but I am interested in square meter. So another 100 centimeter, it means another 1 meter. So I want to convert 50 centimeter squared. It is equal to 0.001, not 1, it's 5.005 meter squared. So I have converted this value in meter squared, which is 0.005 meter squared. So if I go back to this equation, area is 0.005 meter squared multiplied by velocity of the liquid, which is 0.3 meter per second, and it gives me the value of 0.0015 meter cube per second. So I have calculated the volume flow rate, which is V over T, and it is equal to 0.0015 meter cube of volume, and it is passing, if I use the definition of the volume flow rate, it says that 0.0015 meter cube of volume is passing in 1 second through a unit area. Okay, so we have calculated V over T. Now if I go back to my question, to my previous solution, so now I know the value V over T, so I need to multiply it with D to get M over T. So here is V over T, and I will multiply it with the density of water to get M over T. So let me write it on another slide. So M over T equals density D multiplied by V over T. And just remember that this V is volume, not velocity. Okay, so density of water is 1000 kilogram per meter cube multiplied by V over T, and I have just calculated it. This V, let's just remember that this is volume over T and this is velocity. It's 0.0015 meter cube per second. So 0.0015 meter cube per second. And now I will use my calculator. Okay, and it is 1.5 kilogram per second. Okay, so we are very close to the answer. Now we know M over T. So let's have a look. So now I already know M over T, and the only thing I need to know is change in the velocity. So let's calculate it. So the initial velocity is 0.3 meter per second and then final is 0. So change in velocity is 0.3 meter per second minus, and the other velocity is just 0 meter per second. So the change in velocity V is the same 0.3 meter per second. Okay, so now we have all the quantities. F is M over T, change in velocity. So let's calculate F equals M over T into change in velocity. So let's see what is M over T. It's 1.5 kilogram per second. So 1.5 kilograms per second multiplied by change in velocity, which is the same 0.3 meter per second. And my calculator tells me that this value is 0.45 Newton. Okay, well, that is the answer of your question. And if you are still confused or if you don't understand some things, please repeat this lecture and listen it again and again until you understand what did I do to solve this question. It's not actually that difficult, but you just... So I just want to add something before leaving. If you are given a question where you are not given the area, here we were given the area 50 centimeter squared, and then we converted it into meter squared, and then we calculated the V over T, and you know all that process. So if you are given the radius or diameter of the pipe, what will you do? Instead of the area, like 50 centimeters squared in this area, if they give you radius or diameter of the pipe through which the liquid is passing, then you know how to deal with that problem, right? Because then you have to take an extra step to calculate the area, and you know it is a circular face, so area of a circle is pi r squared. So first we will calculate the area from that radius or diameter. If it's diameter, you have to convert it into radius, and then you can use this formula to find the area, and then rest of the calculations are same. Similarly, if they give a different liquid, because in this question they told us that the liquid was water. Water normal to the wall is 0 after striking. But suppose if they give not water, they say that oil is passing through the pipe, and then they mention this problem. What will you do? What will be the different in the calculations? The only difference in the calculation would be the density. So where we use the density of 1000 kilogram per meter cube for water. But if the liquid is not water but it's oil or maybe milk or maybe mercury, whatever it is, you have to find the relevant density of that liquid. Logically they should give you this value within the question. So they will give you that whatever liquid they use, they will give you the value of the density for that liquid. If not, then you may ask your examiner to provide you this value, because anyway this value should be given to you. You are not supposed to remember this value. So whatever liquid they use it, they must give you the value of the density as well. So I hope you can manage this question well. The last point I just want to clarify, I mentioned when the water is coming out of the pipe here is like it is diverging. So experimentally, if you see, if water is coming out of the pipe, the water is parallel alongside the pipe. So it is not like diverging, it comes out almost like the parallel lines. So just I want to clarify that it is not diverging like it is coming all the way around. Actually the liquid is coming horizontally alongside